Hey friends, thanks for tuning in. If you wanted to watch this video instead of just glancing at the notes on your own, feel free to do so. But I just wanted to make sure you were good with some terminology from last year. First and foremost, you're asked on this note sheet to label the quadrants, and if you remember, they go in the direction of a capital C. I guess it could be lowercase too. But we call this quadrant 1, quadrant 2, quadrant 3, and then we have quadrant 4 over here. Now, when you're asked to complete this, you're going to see that it says that an angle in standard position has a vertex at the origin and its initial side coincides with the positive x-axis. The other ray is the terminal side of the angle. So by definition, when you draw an angle, we always start at the origin and make what we call the initial side. So this right here is our initial side, and it's always made with the positive x-axis. The positive x values. Now, what you're going to do is take this ray and rotate it. If you're talking about a positive angle, you are going to rotate counterclockwise, which I know we don't have a lot of these clocks anymore, but you're going to go obviously in this direction. And what you're going to do is rotate it whatever the number of degrees you're asked to rotate it is. Now remember, each axis represents another 90 degrees. So this is 90, this is 180, this is 270, and then when you make it all the way around, this would be 360, and then it keeps going. So you can think of this as 0, but also 360, but it does keep going where you can keep adding 90 to 360 and then add 90 to that to keep getting these measurements that are over 360 degrees. So if you're asked to graph an angle 170 degrees, you would just want to be close to that axis right here and then show the direction in which you rotate it. So that is how you'd graph a positive angle. And then to graph a negative angle, same idea, where you're going to start with that initial side, but then instead of rotating counterclockwise, you would rotate clockwise. So as I labeled the axes before, we would then call this negative 90, negative 180, negative 270, negative 360, and so on and so forth. So if I said graph an angle of negative 240 degrees, well, you're going to go just shy of that negative 270 and show the arrow in which the direction that you rotated was. Now, we call, obviously, the initial side, the side where you start, but where you end, we call that the terminal side. So for this angle over here, the terminal side was right here. And then for this angle over here, the terminal side was this piece right here. It's that ray that represents where you end. Okay, so that is some basic terminology. Now these next 4 problems practice graphing angles. So what you can do is pause the video at this time and try to do parts A through D, and then watch the video at, replay the video or play the video, and you can watch to make sure you got all of these right. So for the first one on here, 100 degrees, you would show that initial side, and then we want to go 10 degrees more than 90, so just go a little bit past 90, and then again, show me the direction in which you rotate it. And then remember, in the directions it said to state the quadrant, so we would call this a quadrant 2 angle. And then you can keep going. So for the next one, negative 85 degrees, you would have your initial side here. We want to rotate in the clockwise direction, and we want to be 5 degrees shy of negative 90, and then showing that we went in this direction, and then remember that that is quadrant 4. To do 560, I already know that that's greater than 360, but the question is by how much? So if I take this and subtract 360, note that I get 200 degrees. So in order to show this angle, I'm going to graph, and I'm going to show that I went one full time around to represent 360, but then I have to go that extra 200 degrees. So remember that this is 90, this is 180, so I want to keep going past 180 and then go an additional 20 and then show that my terminal side is here. Okay, so just make sure I can clearly see that spiral that you went more than one time around. And then final example here, negative 320. So we can make that initial side. And then if you have to label your axes or just count, remember that this is negative 90, negative 180, negative 270, negative 360. So note that I'm 40 degrees shy of negative 360. So I'm going to be, somewhere around here. And then I can show the direction in which I rotate it. And then going back, this one is quadrant 1. And then going back to this last one, this is quadrant 3. So that is how you graph angles, whether they be positive or negative. The next part of the notes deals with radians. Now, we're going to get into the unit circle together. So you're going to see on this sheet right here, it talks about like all of the different angles on the unit circle. But in order to talk about radians, we have to convert degrees to radians, or the other way around. We have to have an understanding of what a radian is. A radian is when you take the radius of the circle and you put it on the circumference of the circle. So when you're talking about this idea of a radian, what you'll see is that if you take the radius of any circle, no matter the size, and you map it to the circumference, you're going to see that by the time you get to 180 degrees, you've gone around the circle 3.14 and then some change times with the radius of that circle for any circle. Now, you guys know that to be pi. So what we say is that 180 degrees is equivalent to pi radians. And again, that's taking this measurement here, so this radius, and basically like taking this and mapping it around. So I can like kind of move it. It's not going to look perfect, but if you were to like bend that line, you're going to see that it's going to go around approximately 3 and then that 0.14 times. And that's where we get this idea of 180 degrees is equivalent to pi radians. Now, if you keep this going, you're going to see that it goes around the entire circle 6.28 and then some change times, which you should know as 2 pi. So one thing that you guys have learned is this idea of a radian, and that to go around an entire circle, it's a 360 degrees, but that's equivalent to 2 pi radians. Now, we will go through together how to label the rest of these using radians, but the key idea here is that if you want to convert from degrees to radians or radians to degrees, you have to have an understanding of one of these two, or any of the ones that you get from the unit circle, but the connection here between the units. Pi is equivalent to 180 degrees, or 2 pi is equivalent to 360. When you want to convert from one type of angle to the other, you have to use this understanding. We actually use that pi is equal to 180 when we convert because it's reduced. So what you're going to do is, because this is a unit conversion, and this is true always, pi is always 180 degrees. What we can do is, if you're asked to convert to radians without the use of a calculator, remember that in order to convert units, if I want degrees to cancel, I need degrees down here, because then those units can cross cancel. But I need to think, what is true about 180 degrees? Oh yeah, it's equal to pi radians. So then what you can do is, if you want to convert, you can either multiply or cross, or I'm a big fan of cross canceling. I know that 20 goes into 180 9 times, so I can actually cross cancel here and then get the solution of negative pi over 9 without the use of a calculator. So 20 degrees is equivalent to negative pi over 9. Now, you can do the same thing for this next part here. 250 multiply. We want the degrees to cancel, so we're going to use this conversion here and put a pi on the top. And then from there, we can go through and cross cancel. I know that these are both divisible by 10, so I can cross off that 0. And then thinking about, does anything go in these two numbers? And I do not believe anything does. That is common. So then we would get our final answer of 25 pi over 18. And that would be a radian measurement. Now, the last two on this sheet, you're going to see deal with doing this, but in reverse. Now I want to take the radians and go to degrees. So again, to get my units to cancel, to get this pi to cancel, I need to put a pi down here. And what's true about pi? Oh yeah, it's 180 degrees. So what you're going to see is the pi's will cancel, giving us degrees in our final answer, but we still have to now use our calculator and figure out what that measurement is. So what you can do, is go to that calculator, and you can just type in 180 divided by 7. and then you should be getting approximately 25.714 degrees. And then you can do the same thing with the next problem. We want to get rid of the radians, so we're going to put pi in the denominator, 180 in the numerator, cancel that. Now, you can cross cancel again, or you can just multiply across since we are using our calculator this time. So if you don't want to deal with the cross canceling work, just because we're going to have to use our calculator regardless, you could do 13 times the 180, get an answer, and then divide that by 8. And then we can get this angle of 292.5 degrees. So we'll do more work with this, but I just wanted you guys to be able to see this, to know how to do some of the problems in the Delta Math. I'm going to pause the video at this time and make a separate video for the next part of this.